Okay, so now this is day 2 of our notes for 3.4. So now we're going to talk about the vertical line test and the horizontal line test, and then how to verify that we have inverse functions. Okay, so in this one, we have the black graph is the function, and then the blue graph, the parabola on its side, is the inverse. Okay, so we're trying to decide if the inverse is a function. So what we use to decide if something is a function is the vertical line test. Okay, so my original function is a function. My inverse, not a function. Okay, so same thing for this other one, the black one here. It passes the vertical line test. Here's my inverse function. It looks kind of like I have a vertical line there, but I don't. It's just gradually getting closer and then gradually getting further. So this one passes the vertical line test. Okay, so we have this thing called the horizontal line test, and what that tells me is if a function is going to have an inverse that's a function. Okay, so the horizontal line test says that no horizontal line has to can intersect the graph of the original function f more than once. If that happens, then the inverse of f is itself a function. So if we think about this function here, okay, that's a function. However, if I try to draw a horizontal line, what that is telling me is that the inverse is not a function. Okay, so if it doesn't pass the horizontal line test, the inverse is not a function. Okay, if it does pass the horizontal line test, so say it looks like this, a line. It passes the horizontal line test because it doesn't ever intersect more than once. So that means that the inverse would be a function. Okay, so if it passes the horizontal line test, then yes, the inverse is a function. Okay. So moving on to example, it says example 5, but it should be example 7. So example 7. We are going to consider this function. Here's the graph of the function. And we're going to determine whether the inverse of f is a function, and then we'll find the inverse. So we look at the horizontal lines. It kind of looks like it might be horizontal there, but it's not. It'll be obvious if it doesn't pass, like it'll be a quadratic or something like that. So this one is a function. So yes, the inverse is a function. Okay, so now we're going to find the function. So we're going to plug in y. And then this is review from yesterday. So we're going to go ahead and switch our x and y. And then we're going to subtract the 1 and divide by 2. And then cube root both sides. So y equals the cube root of x minus 1 over 2. I don't need a plus or minus because that is an odd root. And then this is f inverse of x. That's the function notation. Okay, go ahead and try, so that's our inverse, sorry. Go ahead and do the next one. Try that one on your own. So pause the video, and then I'm going to solve it here. So I'm going to put a y in there first. Then I'm going to switch x and y. And then I'm going to solve. So the order I have to do this, I have to add the 1 first so that I get the something cubed by itself. So I have x plus 1. And then I'm going to cube root both sides. So I have the cube root of x plus 1 equals y plus 3. And then I'm going to subtract the 3. Okay, when I subtract that 3, it has to be on the outside. So make sure your cube root looks like that, and then you have a minus 3. If you want to put it behind it, that's okay. Or you could do -3 plus that equals y, which then you have f inverse of x equals -3 plus the cube root of x plus 1. Or you could have written it as the cube root x plus 1 minus 3. Either way. Okay. We're going to go ahead and verify that functions are inverses in our next video.